Hello, Human Physiology. Welcome to section 3 of the respiratory system. We're going to go through the mechanism of breathing. This is going to be the physiological concept for this unit. And we're going to start basically looking at the process of inhalation. And to inhale, it essentially means to inspire air or bring air into the body. Now, we've already gone through the anatomical parts in the mouth and the nose and the throat, most notably things like the trachea and the bronchi and the alveoli in terms of how it gets in and moves it and exchanges its oxygen and CO2. But now we're going to look at the moving parts of how we have the ability to do this. Breathing is voluntary and involuntary. We can hold our breath purposefully, whereas we can't really hold our heartbeat to compare it to something else. But breathing will occur involuntarily on its own. So one of the major things we understand is the fact that we have this diaphragm, which is a muscle that sits right above the stomach. Okay, and it moves downward, and the atmospheric pressure in the alveoli falls. So essentially, what happens is that diaphragm, we're looking over on this side on the right, is actually going to drop, and that is going to expand. As you can see, I'm making with my cursor. It's going to expand the lungs out, and what that's going to do is it's going to change the pressure, and it's going to actually help draw air in. So when you take in a breath of air, like I just did right now, I can literally feel my stomach kind of drop. So take a second and just take in a breath of air. And you'll also notice that as you do that, the rib cages kind of lift up. And that's going to be our second focus. You have muscles that are in between all of these ribs. We didn't go into that much detail with the intercostals in our muscular system unit. But if you've ever eaten ribs, that's the meat. That's intercostal muscle, which is in between each of those ribs. And those muscles inside the ribs are going to contract. And what that's going to do is, since the muscles contract, it shortens. It's actually going to raise the ribs up, as well as the sternum, and enlarge the cavity even more. And this is going to allow us to breathe better. Now, those of you who are in choir or sing know that this is a very, very important science for you to be successful. Okay? Because those of you that can draw more air in, can carry a note better, and it just makes you a better, I guess you could say, better singer. So far what we need to do is we need to inhale air. We use the diaphragm as well as muscles in the ribs to enlarge that space. Now, the key point I want you to understand is that it's going to deal with pressure, okay? Pressure and volume. All right, so it kind of talks through some chemistry. Boyle's law would be an example where we have a pressure-volume relationship. So let's move on. All right, now step 3 of this inhalation, we have basically changed the pressure. We have dropped the diaphragm, making a larger volume. We have used the intercostal muscles to enlarge the area. Now we're going to focus on the pleural membranes, which are going to be on the very inside of the lungs. And the pleural membranes, held tightly together, move with contractions of the muscles. So those membranes are going to allow for this inspiration of air to take place. Now, what should be noted is that these membranes are mucousy, and that allows them to not stick together. Finally, we have the last 2 steps of inhalation. And step 4 is we're going to talk about the surface tension in the alveoli. And that kind of makes it difficult to inflate them. So something called surfactant is going to reduce the tendency of alveoli to collapse, which is very important. Because as you bring that air in, you're going to want to create a surface area around that alveoli so that oxygen can be exchanged. That is the key to basically every single system in our body, is we try to be as efficient as possible. So I want you to imagine a grocery bag filled with grapes. If you have way too many grapes in there, there's not going to be any area or volume inside there for that air to move. So what we like to do is create a large airspace around all of those grapes. So when we breathe in, that air can filter through all of those grapes to all the available volume, and surfactant is going to help reduce the ability for those grapes to kind of clump together. So the alveoli are going to be having plenty of space for that air to move over them and exchange their gases. Now, last thing I want to talk about when we inspire or inhale is the fact that a deeper breath can be achieved through other muscles. So if we focus on our pectoralis minor and sternocleidomastoid, which is going to be in our neck, and then the pectoralis minor is going to be in our chest, we can actually create a deeper breath. Essentially what we're doing is we're expanding out this space, and we're making it larger and larger so that we can bring in more volume of air. What that's going to do, it's going to give us more opportunities to exchange gases, and therefore, if we're singers, take a longer breath, hold a longer note. So that is the inhalation. Let's move on to the next steps. So before we move on to the next steps, I forgot to mention there is a kind of a side note. The first breath of a newborn is usually the hardest, okay, because all the alveoli are only partially inflated. So think about when you were born, those grapes are kind of like wrinkly and moldy. Well, not moldy, but wrinkly. They don't have their true spherical shape. So that's a lot of times what's difficult for newborns is because it's difficult to get that air in there and inflate and create those pressures. A lot of mucus in there, and they haven't needed to be used so far. We've been relying on the mother's blood through the umbilical cord to take care of the necessary gas exchanges. So that's just kind of a side note. It's not really a step of inspiration, and nor is really 5. Inhalation has 4 steps. 5 and 6 I just kind of put on here as a side note. So now that we have that air in here in our lungs, we're going to exchange it in the alveoli, which is going to go into the capillaries, and we're going to put oxygen in and take CO2 out. Now we don't want that CO2 to stay in the body, so what we're going to require is to get that air to expire, and that means to get rid of, out of the body. So a couple things to know. We're basically going to go in reverse. The diaphragm, which we noted is this muscle right here, is actually going to relax, and when that muscle relaxes, it pushes upwards. And that is what we call an elastic recoil. So think of it in terms of if you're pulling on a rubber band and you let go of that, you haven't contracted, it's going to go back and recoil to its shape. So during inhalation, you were pulling on that rubber band. During exhalation, you were letting go. So you're releasing that surface tension. And what that's going to do is get that air to move out of the body. So if a person needs to exhale more air, internal and external intercostals will assist the exhalation process. So again, remember those muscles are in between each of the ribs. We have some that are internal or deep in the body and some that are external, a little more superficial. So what do these contractions do? So when these muscle contractions take place, they increase the air pressure within the pleural cavity. Now think about how that's going to work. If you have a space, let's say you fill up air in a balloon. That balloon has a volume and it has a pressure. The pressure essentially deals with KMT, kinetic molecular theory, and how the molecules of air are moving through the lung. Now, if you make that volume smaller, Boyle's law will say if you decrease the volume, what happens to the pressure? The pressure should increase. You're squeezing on that balloon, causing more and more pressure, and essentially it could pop. So why are we utilizing this pressure in the pleural cavity? What we're doing is we're trying to push up on that diaphragm, make that volume smaller, and essentially cause a higher pressure. And there is only one way in and one way out. So that pressure is going to look for the nearest point of least resistance, which is going to be back up the tube it came down and out the mouth. And that's going to really help with this exhalation process. So essentially the goal that I want you to understand is that our body uses muscles and it uses pressure and it uses volume in order to inhale and exhale the air that we breathe. A very, very efficient system. So to kind of sum it up, I have a nice little picture here for you to kind of look at. But we'll start up here on the left. As air is inhaled, as we review here, it's going to go down, and the diaphragm is going to push downward. It's going to contract, and when the diaphragm contracts, essentially gets shorter. And as it drops down, it's expanding. And what's going to help with that expansion is the rib cage, all right, and the muscles, the intercostal muscles that are in there. So as the diaphragm contraction moves down, we're creating a larger volume, dropping the pressure, and that's actually going to pull air in, which is kind of nice. I didn't mention that before, but it's really going to help draw air in for you, okay? So, and then on the opposite, we want to exhale that air. We're actually going to relax the diaphragm. It's going to go back up and recoil to its original position, and that is going to essentially drop the volume, increase the pressure, and want to push it out. So what is the goal of this mechanism of breathing? It's just to efficiently utilize our body, the muscles, the pressures to exchange our gases. Okay, so inhalation versus exhalation, understand how the diaphragm works, understand how the pressure works and the volume works, and how these rib cage muscles, the intercostal muscles, can assist us and make this easier. Now, as a side note, going back to singing, it's very, very important in band and choir to make sure that your posture is very strong. If you slouch over, you can imagine that you're actually creating a smaller volume for you to breathe. So it makes it difficult to hold notes and sing and play an instrument. So having your chest up high, you feeling your diaphragm, kind of pushing your stomach out and dropping your head back, actually creates very efficient airways for this to happen. So don't underestimate the power of a good posture. All right, last thing that I want to talk about in this section is some non-respiratory movements, some things that we do as human beings and other mammals can do as well that actually don't deal with breathing at all. One of them would be coughing, a deep breath followed by forceful expulsion of air, and that's going to be to clear anything in the lower respiratory tract down in the lungs. So a cough is kind of an involuntary response, although we can also voluntarily do that, but we're going to take in a deep breath of air and we're going to contract all those muscles really, really hard and push stuff out. Next one we'll bring up is a hiccup. Hiccups are very common, especially in babies, where they basically have a spasm of the diaphragm. You can imagine, based off what we just learned, what that's going to do. It's going to contract, relax, and push air up. And it's going to have kind of what we call a spasmodic closure of the glottis. And the glottis, remember, the epiglottis is that flap that's going to prevent food from going down the windpipe. So essentially, you kind of get like that air trapped, and it just pops that epiglottis and kind of makes a noise. So there's two things that cause that, and that's irritation of the diaphragm and some of the nerves that run in there called the phrenic nerve. The phrenic nerve is basically responsible for this hiccup. And a hiccup is your body trying to tell you that you need to restart your breathing. It's either not at a good pace, you're not getting the necessary oxygen, you're getting too much oxygen, too much CO2, and that's involved in that process of hiccuping and restarting and spasming those muscles to get you back on track. All right, so sneezing is the next one. Air forced through the nose to clear the respiratory tract. So that's very similar to coughing, but we actually push it through the nose. And if you've ever tried to sneeze, with your eyes open or things like that, that's always something that we try to do, or maybe we've done in our lifetime. Sneezing is an involuntary response. Your body has something inside it wants to get out, and it has a clear method on how it's going to do it. Yawning is a deep, prolonged breath that fills the lungs and increases oxygen within blood. Now, I always depict as yawning as you get really, really tired if you're anemic. And if you are not getting enough oxygen, maybe you're not breathing as deeply, you start to get really tired and essentially almost anemic, so to speak. So your body causes you to have a deep, prolonged breath that really fills the lungs with a high volume of oxygen. So yawning is your body's way of telling you, hey, we need some more oxygen in the blood. So this kind of wraps up our section 3 on the mechanism of breathing. Section 4 will be our last section and our last unit, and that's going to be on how we go about controlling our breathing. So that's all I got for now. If you have questions, feel free to see me. If I am not there, feel free to email me. I'd be happy to discuss things with you. All right, Yago, out.